and they typically emit around 30% of the fuel unburnt straight into the local ecosystem. So it can cause harm to the local maritime ecosystem as well. And I think the last one here goes kind of for all electric mobility solutions that moves from fossil to electrification. But of course, we need substantially less primary energy because we have a much higher system efficiency compared to fossil alternatives. So why has electrification been so slow in the maritime sector? Well, there's a couple of different challenges that you need to overcome. The number one being the heat that is generated in the motor, but it's also problems around volume and weight and transmission, which also adds a lot of complexity because propellers typically operate on lower RPMs and electric motors are easier to do when they operate on high RPM. So that's a big difference. And of course, it's in water, so sealing becomes also a critical component. And if you look at a conventional sort of motor design, which you see on the left-hand side here, it's typically very big and heavy. You have a motor, typically a motor that operates on pretty high RPMs. So you need to have some kind of gearbox to make it useful for the range where the propeller is effective. You need to have kind of a mechanical shaft that goes out through a mechanical seal. And you need to cover it in a void, basically, where you can put cooling solutions and things like that in place. So a traditional motor is typically cooled just on one surface, whereas what you see on the right-hand side is what we have developed, the Zparq, which is up to 10 times smaller by volume and weight compared to alternatives in the market. We have a unique patented cooling technology, so we actually embrace the water rather than mitigate the water. So we have a motor that you can put directly into the water. We use the surrounding water to cool the outside. We have a hole in the middle that allows water to flow through the motor. And then we have, which is the core patent, a solution that circulates the water in between the rotor and the stator. So we are actually cooling 4 surfaces of the motor instead of 1, which is the typical case. And because we can cool the motor so much more efficiently, we can push much stronger current through the windings, basically. So that's how we can make our solutions so extremely compact. Also, we have very few moving parts. We basically just have one bearing in the front and one bearing at the end. No transmission, no gearbox, no complexity around that, and no sealing, no void. So the solution as such becomes very simple, but very small as well. And of course, that gives a lot of different advantages. To start with, it gives us superior system efficiency, which kind of can be translated into range or payload capacity or whatever you want to optimize your use case based on. It means that it's extremely robust. It means low maintenance. I can add to that we're also gathering around 200 data points in real time in the motor. That's to optimize how the motor is working, but it also gives us very good indications when something in the system is on its way to degrade. That basically means we can work much more actively with proactive maintenance rather than ad hoc maintenance, which is, of course, a strong sort of operational benefit. It's also extremely silent and has a low signature. That can be important both from environmental reasons. It basically means less noise pollution in the marine environment, but it can also be very significant in dual use applications. Because of the very efficient cooling we have, it has a very low IR signature. Obviously silence is a core capability of the motor, as the motor is also submerged into the water as well, so it becomes additional layer of sort of sound dampening on it. It's submersible and deep sea ready. It's self-cool, like I said before, but it's also been pressured out. It's tested down to 1,000 meters. So it's useful for both sort of surface vessels, but also anything that you operate under the water surface as well for longer time frames. I think the last bullet is something that has obviously popped up as more and more important over the last couple of years for sad reasons. It's scalable and resilient supply. We designed the entire system end-to-end ourselves, which basically means that we can We don't have any sort of single source dependencies in our supply chain. We can put production wherever we think it makes sense for whatever use case we are pursuing. So that basically means that we can shift supply chain from Asia to Europe to US, depending on the sort of needs that we have as a company. But another part of it is obviously that we are a factor 10 smaller than a lot of competing solutions, which basically means that we'll use a factor 10 less material in production as well. So we need substantially less raw material to produce our motors. It's also extremely modular and scalable. So we use the same core components across a wide range of different applications. I think what you've seen most in our sort of marketing is the outboard system, the Z10 system that you see on the top right. But we also have different other type of solutions such as sail drive. We can integrate it into hydrofoils. We can do counter-rotating propellers. But we use exactly the same core components. We use the same pod, with the same inverter, the same control unit. The technology is also scalable with the same architecture. So we've been focusing mainly on the 10 kilowatt solution to date, but we've done prototypes up to 50 kilowatt, and we're actually working now to sort of commercialize that as well. But the technology is scalable up to megawatt size, which is pretty big affairs that you can operate on that. Moving on, this is basically what our portfolio looks as of now. We have kind of two main tracks, you can say. On the left-hand side, you have our OEM system, which is kind of the building blocks, where we assume full responsibility for a critical component, namely the sort of electric propulsion of whatever vessel you're developing. We assume full responsibility for sort of the end-to-end workings of that system, so that if you're a naval architect or a platform developer, you can spend your engineering hours on whatever helps to differentiate your own product, basically. And like I mentioned before, we have an exceptional form factor. It's only 4 kilos, the pod that you see here. It's 10 kilowatt, so that's equivalent of 15 horsepower. And it's only 82 millimeters cross section. So it's literally like a beer can, but it gives you 15 horsepower. Outboard system on the right-hand side, it's only 70 kilos, which is substantially less than other solutions in the market. It's designed to be a plug-and-play solution where we have focused on getting it end-to-end certified. We also develop our own battery packs, like you see on the white one here. It's a carry-along battery because we think you should not be dependent on charging infrastructure on the dock. So you can actually carry them home. It's the same form factor as a typical fuel tank and the same weight. It's around 20 kilos. So you can carry them along to your summer house or wherever you need, wherever you have this sort of charging capacity. Like I mentioned, we are planned to do the 20 kilowatt and 40 kilowatt for early 2027 launch. So those are already in development. There's a little bit sort of history of the company. Like I said before, it was founded back in 2020. What you can see, the yellow thing there is a research vessel that has been under the Arctic ice shelf, and that's also the background why we had pressure tested the motors down to 1,000 meters. We've been working with leading marine technology companies to develop propulsion systems together with them. We work with the Swedish Sea Rescue Society to develop their first set of hydrofoiling rescue boats. And we have now entered kind of the commercial stage. We are selling to commercial customers, and not only pilots or proof of concepts, but actually customers that are sort of paying what we want them to pay for our solutions, which is a great milestone for us as a company. And as we imply under, we work with dual-use actors as well. So it's a pretty good set of demanding customers as well that is really stress testing our technology, and with good remarks to date. Coming next 12 months, we will, after the summer, open up for a Series A round in the range of 10 million euros. The money will be used mainly to expand sales, accelerate the dual-use deployments, and work with industrialization as well. We're working with Renault on that part. We have already to date secured 5 million euros from EIB and existing investors. So that's pretty much it for me. Open for any questions or comments, or that's maybe later, Magnus, or...
No, that's fine. Thank you so much. A very good presentation. And, I I really think you're an amazing company to work with, so I don't have to talk about that. Maybe you could mention a little bit about the size of your company. How many people roughly are you and something like that?
Yeah. We're currently 12 people in a company, mostly engineering, I would say, but we recently expanded our sales team as well. So we're more getting into sort of the commercial stage of the company. That's also where we're looking at ramping up is both engineering capacity, but also sales team as well as we grow as a company. We've been focusing quite a lot on sort of establishing kind of a blueprint for how we sell and how we deliver. There's a lot of emerging actors in this space with unmanned vessels and things like that. So we want to make sure that we don't invest too much engineering time in each one of the cases. So we have to focus a lot on getting very well documented mechanical, electric, and digital interfaces. And we got the feedback so far from our customers that our solution is extremely easy to integrate compared to alternatives. We're talking 20 minutes rather than weeks. And I think that's a lot of the value that we can contribute to any kind of project developers that are sort of focusing on other capabilities. But of course, the electric propulsion is a critical capability of any solution.
Super. I don't see any questions. Maybe to the latest arrivals. Feel free to drop questions on in the chat. We try to take them after each presenter, but we also will follow up in the end with the remaining questions if there are any. So thank you so much. Let's go on to Magnus at Roxen. Are you there somewhere? I guess you are.
Yes, I'm here.
Perfect.
Share my screen.
Super. So we stay in the water, so to speak.
Yes, definitely. So,
Perfect.
as Magnus said, my name is also Magnus, but Magnus Sundstedt. I'm a co-founder of Roxen Innovation and also the CEO currently. And we are definitely a maritime company. We have developed extremely lightweight electric watercraft. We have been in business pretty much similar time as Zparq and have made a similar journey. But of course, everything started as for us, maybe not for Zparq, but for so many other companies in a garage. So 2021, I and two of my engineering colleagues had an idea of doing something completely different compared to traditional watercrafts. So as maybe some of you know, traditional watercrafts are quite heavy, quite noisy. You're not able to do like the guy you see on the right side of the presentation here to pretty much pick it up by hand. Traditional watercraft is around 200, 300, 400 kilos. So you need a trailer, a crane, or something to be to launch it and deploy it. Fully Swedish design, of course. So even if we started up thinking that doing something electrical on the water is must be something good, actually the lightweight and the portability is our main unique selling points, I would say. So innovation is of course the key and heart in the company. We came, all of us, from the aviation sector. I mean, Reshaping is pretty much the city of aviation in Sweden, where you have the Gripen aircraft, the fighter. So we have been working on that, all of us, and knew how to make complex things lightweight and still have high performance. So that is typically the values we also share in Roxen Innovation. As Andreas was into, I mean, there is a change ongoing at sea and in the water, but it takes, unfortunately, a bit longer time compared to the automotive industry. But you have to start somewhere, and we had pretty much the same idea and the same concept that having a very lightweight vehicle also made it easier to have a electrified vehicle, because then you're able to pick out the battery and take it to your charging station, typically ordinary 230 outlet. The same principles you have for your electronic tools, typically screwdrivers and things like that. Also, of course, since we live all of us along the Roxen lake, so if you don't know it, I mean, Roxen is a big lake outside of Linköping, and as so many other places among our coastline, there is a lot of activities, of course, which is good, but unfortunately the watercrafts of today, the more traditional, make a lot of sounds and are disturbing not only us old guys, but also the wildlife and so on. So doing a more quiet but still fun product was of course one of our visions within Roxen Innovations. This is typically very good picture of how it works. I mean, not so many boats, not so many definitely not so many watercrafts could be placed on top of your roof rack and then simply be carried down to the sea line and start having fun. So this was, of course, what do you say? Like a challenge for us, engineering challenge, but still, when we started on a white paper, we didn't have any legacy in old designs and things like that, and that made it, I think, a bit easier for us to actually come up with this innovative solution. We, as Zparq, also have a battery design of our own. That was not the intention when we started, but it ended up so, because it was not so very easy to find a fully waterproof battery that was removable and also were able to perform in the way we needed and wanted. So if you have one battery, you can typically run 1 hour in mixed driving. And then you can simply exchange it, as I said, to another battery, fully charged one, and drive another hour. And this is essential, of course, for especially the rental companies that want to have their watercrafts and jet skis running, not 24/7 maybe, but at least from 9 in the morning to 9 in the evening. Some other engineering piece we are extremely proud of is the powertrain. It's not yet based upon the Zparq motor, but as you might have seen, that Zparq is coming up with a 20 kilowatt engine motor for next summer. That will of course fit perfectly into our power line. So I'm waiting, and hopefully we'll get the first one in our powertrain for the next season at least. Also, I mean, our vision was also to be fully Swedish or at least European production company. So the goal is, of course, to have as much as possible made and assembled in Sweden, and also getting parts from the rest of Europe. The battery is still a problem, as you all know, but hopefully we'll have a solution for that in upcoming years. Software is, of course, also something that drives innovation, and also, of course, are coming more and more into the modern maritime vehicles. So we added typically things that we took from the aircraft industry in regards of security and safety and robustness, and also added like geofencing and fleet management, fully connected system, so you can feel safe when you are having fun on the water. Finally, of course, sustainability was well, one of our cores, as said earlier, and it still is. That's why the design of our watercraft and jet ski is a bit different to, well, ordinary. For instance, we are not making it in carbon fiber or glass fiber or something, well, some other of these fancy materials, because that takes typically too long time, and it also means that we have to put production in Asia in poor, well, work conditions and so on. So to be able to scale up and produce, well, several thousand of these vehicles in the upcoming years, we decided instead to aim towards more sustainable production methods. And lately, just a few pictures of how you typically will and can see our watercraft the upcoming years, either if it's in our own, well, nice landscape, or down in the Mediterranean, France or some other. So that typically ends my presentation, and I'm happy to take questions or comments from all of you.
Thank you so much, Magnus. Very good. Lovely company. I love this company too. And I think you could add something maybe on your financing.
Sure.
Generic.
Yeah, no, as I said, we started quite, well, how do you put it, cost effective, 3 engineers in a garage, and don't cost so much. So we worked for 3 years in that, typically worked as a consultancy, consultants, and then spend our free time and weekends in the garage. So our first investor was actually only 2 years from today. And since then, we have closed, I think, 2 other rounds. And in total, we have typically been funded by business angels around, well, 1.2 million euros. So it's fairly low amount of money that we actually had to, well, get into the company to get to where we are today. And that is like full production and 40, 50 orders that should be ordered and delivered now this season.
Yeah, I think it's an extraordinarily low development cost to put my view of that. Do you have any questions, the audience, or either you send them on the chat or we pick them up after the last speaker? So I see nothing on the chat on that. I have a question for you, Andreas, but that will wait to the end. So let's thank you so much, Magnus, again, and let's shift gear and let's talk to Björn. Are you around? I can see you at least.
I'm definitely around.
Great. So share your screen and
there we go.
Yeah, it's not here. Yeah, here we go. Perfect. Take it away.
Still on the mobility path, and I will let you know a bit more about what happens if you combine Formula Racing or Formula One technology with IKEA modularity and processes. Then you, of course, get LUV, or light urban vehicles, which is what Lovely stands for and work with. We are looking at the problem of EVs not scaling. As you all know, it stopped, except for in Norway, or the pace had been reduced anyway when it comes to the growth. And I tell you a bit more about what we see as the why and what can be done about it as well. So we have developed a way of building cars in composites instead of steel. So massively reducing cost, weight, and still keeping safety at the same level as a regular car. So this is our unique patented technology, and I will tell you a bit more about that too. Who are we? We are a small, focused, experienced team with background from business development, composite technology. We have a world-renowned designer in our team, Joachim, and we have built this company stone by stone, mainly over the last 5 years. It took us 5 years to get a global patent for this technology, and since 2021, we have been scaling. And as far as we found, we are the only one in the world who can solve what we call the impossible triplet, to bring affordability in small cars or last mile delivery vans with a retail price sub 10,000 euros. Safety comparable to a regular A or B segment car, and extremely good sustainability impact, of course, given the lightweight. I will come back to that. And we don't see the change happening if you don't compete with prices of second-hand cars on a global scale. You don't reach the big masses. You don't reach the middle class or below, because the budget for a new car isn't there. So we need to come down at around the same price level as small ICE cars were in the past, around 10,000 euros for a new car. And that is actually what we benchmark ourselves against. So we don't look at the 70 million new cars that are produced every year. We look at a couple of billion cars on the roads today that need to be removed from the roads over time. And by building success in that space, you need to ensure that the mileage cost is getting more interesting. So you get a new product, less repairs, better insurance levels, and a lower mileage cost. That is our objective. A quite small one, as you understand. We don't think it will happen at all without safety. I mean, there is a lot of microcars out there already. Renault done one of the first stabs on this. Citroën has done it, Opel, Fiat, and a number of other smaller startups. None of them provide safety. I mean, you've probably seen all the kinds of moped cars, as we call it in Sweden, the L6 or L7s. They are totally lethal if you go into a crash situation. So what happens if you crash a lovely O at an impact speed of 50 kilometers an hour? This is actually a prototype chassis, so it's not optimized, but this is the sort of work we've done with one of the biggest OEMs in the world. And by adding our ease onto it, this is what happens in 50 kilometers an hour into a rigid barrier. So you will have sort of acceptable levels on head and neck and thorax sort of accelerations, and you will be able, as long as you're belted, you can step outside and survive. If you have airbag and belt tensioners, we will even comply with Euro NCAP testing. So why do we do this, or why did we start from the beginning? Because we saw there is no other way than lightweighting. If we want to reduce the emissions from cars, and actually at the end of the day keep the car as a mobility alternative, we need to lightweight. And downsize. We call it right sizing, as the average usage of a car, except standing still for 95% of the time, is actually transporting 1.2 persons less than 50 kilometers a day. And you can do it in any kind of Tesla or Volkswagen, weighs around 1,800 kilos. Electrical one produces 15 tons at production CO2, or you can do it in an LUV, which is a fraction of that. And you have gains over the whole life cycle. We actually taken accepted, tested practices from the aerospace and racing domain and made that as simple as possible as a chassis. So a chassis to a lovely oak weighs around 60 kilos, like a Roxen, and it costs around 400 euros. So that's actually the disrupting part. On top of that, you can actually assemble them close to the customers. Microfactories close to the big cities around the world. Super cost efficient. You can fit 50 vehicles in a regular 40-foot containers if you don't assemble them. And then you assemble it close to customer. On top of that, it's a platform which enables actually the design of a multitude of different vehicles, from regular family cars through logistic vehicles, sort of camper vans, all the way down to sports cars. And all of those pictures, we are actually designed chassis for those vehicles. So super simple, super advanced way to use composites. And it takes around 20 minutes to assemble chassis. It's around 8 man-hours manually to build a lovely O, which is extremely low. If you robotize, it's even less. You can do several sort of looks on the same chassis. You can do different sizes, as I said, family cars, or adapt it to different geographies in the looks. We have done taxi sort of designs for the big sort of taxi operators around the world. We talk quite much to last mile delivery companies. We looked at sort of replacing the existing structures in robotaxi operations. And we even done sports cars as an attempt for a couple of brands. So it's super fast and super simple way to develop new vehicles. And to go from zero to a full vehicle on the market with a manufacturing facility is less than 10 million euros, which is unheard of in the automotive industry. And we see strong trends towards smaller and lower costs in the automotive industry, which is under extremely pressure. And we see our contribution as actually bringing an iPhone moment into the automotive industry. So we license our technology to big players around the world. We have some traction in Europe. We even more traction in Asia, where they reach the bottom of the cost curve and can't go any lower with existing sort of manufacturing methodologies. And even Ursula von der Leyen mentioned in her speech of the nation last year that Europe should have its own e-car, which is economical, environmental, and efficient. So what we can do is actually to add safety and cost down to the existing vehicles out there. We did our first sort of deal with a big OEM last year, tech evaluation deal, and we're working towards our first license deal this year. We are in talks with quite a few different OEMs around the world, but we're also looking into starting a manufacturing facility together with EIT and EIB. And we reached break even or a small profit for the first time last year. Still small numbers, but one single deal on the license side will flip everything quite fast for us. And we are super efficient, just as Roxen. We spent around 2 million euros over the last 5 years, plus quite a bit of sweat equity, and around 500,000 euros of loans in patenting a new tech platform, delivering a couple of generations of prototypes, and starting discussions with OEMs around the world. And now the focus is entirely on sales. So we're signing a number of sales agents, and we are doing pretty much work on the sales side all over the world as we speak. So we're raising around 5 million euros. A first close to deal with what we already have contracted will be around 1 million euro during the fall. Fundraising takes forever. Magnus told before the meeting that you never stop, and I can copy that. I've been fundraising constantly since we started Lovely, more or less, and I don't see that we will stop in the next future. So anyone that wants to discuss joining hands with us and EIT Urban Mobility, who's already on our cap table, please reach out. I mean, the tech is there, the patents are in place already, and now it's all about scaling globally. Thank you very much.
Great, Björn. Thank you very much. I've seen this presentation and in probably 50 times. You know, it gets better and better for every time. I really admire your efforts with Lovely, and I'm sure it's going to pay off soon. So, do we have any questions right away for Björn, or should we wait until we end this little thing? I see nothing in the chat. So let's let you rest a little bit, Björn, until we have listened to Henrik from Electrify.
Yes, thank you, Magnus.
Great, I was happy you were still here. So no, that's great. Thank you. So share the screen and let us.
Yeah. Is it visible now?
Perfect. Take it away.
Wonderful. Thank you, Magnus, and thank you to the other speakers. I'm very happy to be part of this lineup. For those of you who don't know me, my name is Henrik Irander. I'm a go-to-market manager at Elon Road. So my job is basically to bring Elon Road and our way of electrification to the rest of the world, which is a very pleasant task. I'll return to that. And for those of you who don't know Elon Road, our mission is to enable large-scale electrification by removing the main blockers, and the central one being price. But we'll start by taking one step back. Although it might not always seem like it, electrification is in fact moving in the right direction. It is growing, and it's growing on a global scale. And yes, it's heavily driven by China. And no, the US administration is not really helping at the moment. But many numbers show that the world is moving in the right direction, not least in terms of EV trucks sales, which I've tried to gather on this slide here today. In fact, the sales of EV trucks actually doubled in 2025. And yes, China was the main driver, but the EU is coming and emerging markets are coming. So the shift is happening, and I'll be surprised if the recent supply chain disruptions in the Straits of Hormuz didn't amplify this development. The problem, however, is that going electric is very expensive. And if you have an industrial fleet, you often struggle with added downtime, costly infrastructure, space constraints, and unmanageable grid peaks. And besides, maybe in China, price parity is generally years ahead unless the market is heavily subsidized. But here is where Elon Road comes in. By letting the roads be the charger, vehicles can charge while operating. In other words, never have expensive designated charging breaks again. But you can operate 24/7 without having to stop and charge. And at Elon Road, we have two solutions with this. We have the standing still or the static solution shown in the right picture, offering up to 150 kilowatts. But maybe the crown jewel of our product portfolio is the dynamic solution shown to the right. Here you'll charge on the move in motion of up to 350 kilowatts, depending on how many vehicles you have on the rail simultaneously. And this is another way of illustrating it. To the left, you'll see the operating pattern using conventional plug-in charging. And many people might recognize this from their commercial cars. So you drive for a couple of hours, then you need to stand still for half an hour, or maybe multiple hours, depending on your vehicle and your battery capacity. But by choosing Elon Road, your operating pattern alters, which we try to illustrate with a wave-like curve to the right. No more inoperability, no more downtime. And what does this mean? Well, it means that you can purchase fewer vehicles if you're running a fleet. You can purchase those vehicles with smaller batteries. And you don't have to be a genius to figure out that the impact this have on CapEx and OpEx is quite substantial. In fact, we've done some modeling ourselves, and yes, we're heavily biased. But in that modeling, we usually end up with the conclusion that the total TCO saving compared to conventional plug-in charging solutions is 20 to 30% if you run it on a, let's say, 10-year project period. And in the majority of instances, this does not only mean that we're cheaper than conventional charging, but we're also cheaper than diesel. So that's basically how we solve the price problem of electrification. But how does it work in practice? Well, our dynamic solution consists of a few components, including obviously the rail modules, as you can see, hopefully in the top left corner, that are mounted in the ground. We also install a power station for a dynamic solution for every 1.5 kilometer. To feed the rail with sufficient power. We install an energy collector underneath vehicles that can pick up the power from underneath. We install an onboard charger to the vehicle to adjust the voltages. And we also offer a software solution that enables our customers to optimize their routes and their energy management. And I'm definitely not an engineer, so if you have questions on this, I'll most certainly forward them to someone else. But I can say that it has been tested in extreme temperatures, and it is snow resistant thanks to internal heating. And yes, it is safe. Rails are only activated when you drive over them. And no, you don't have to drive precisely over the rails. The sensors enables that the energy collector keep track of the rail and move it horizontally. As you might have figured out already, today the ports are our main segment, not least in California, which might be our flagship project at the moment, which we're doing together with the International Transportation Service, ITS. ITS is an organization that enjoys high pressure from the state government to decarbonize, and early saw the impact that Elon Road can have on their kind of environment. And as you can see in the top picture here, we have our static solution already operational. I think it's a small Zparq terminal tractor that you can spot. And as of 2 months ago, we've also installed our dynamic solution there. So 400 meters of electric road installed, and they're just awaiting some more electric vehicles in order to go live on that one. Another project we're very proud of is with Roxen in France. The ambition here is to install 2 kilometers of electric road on a highway outside Paris, and we're currently there's a video conducting some tests here. Oh, we even got music. Another one that we're very proud of at the moment is our collaboration with the Japanese automotive component manufacturer Aisin. Together with them, we built a test track in Mons, Belgium, 750 meters of electric road, and they are actually satisfied enough to have been asked us for an extension of the project to India. So this is a very promising development in that partnership. Another video. Last but not least, 2 hours from where I'm sitting now, in Ljungby, Kalmar, have a test track with our dynamic solution. Kalmar, famous for their beautiful red port vehicles. As I mentioned, we've installed 200 meters of electric road, and they're using the rail to demo their vehicles as a packaged solution with our charging equipment. That was actually all I had. Thanks for your attention. Happy to take questions.
Thank you so much, Henrik. Maybe you should just mention something about your last round.
Happy to. We just closed our Series A round, gathering 7.8 million euros, if I'm not mistaken.
That's good.
Yeah.
It was a lot of very hard work, so I really appreciate your success with that. Let's see if we have any other questions coming up. I would like to start to ask the question that for you, Andreas, it came from Peter, I think, in the beginning here. Andreas, with this Z10 on board of 1TS, what would be the approximate range? What is the defined defense angle?
Yeah, sure.
It's two questions. So it's what would be the range if you had a boat of 1 tons?
Yeah.
And then the other question would be what is the defense angle of this?
Sure. I can start with the first question on the sort of range. I think that's a fairly tricky question to give a sort of straight answer on because it's a combination of a lot of different factors, the hull shape, what kind of propellers you're using, how fast you're moving, etc. But to give you kind of an indication, we are using a 10 kilowatt Z10 system today on a variety of vessels, but typically in the range between 4 to 5 meters. They typically operate on a weight which is 300 to 400 kilos. They typically cruise at around 15 knots, just to give you an idea. So our sort of standard carry-along battery packs is slightly more than 6 kilowatts. So that basically gives you at a sort of cruise speed, we consume around 7 kilowatt, I would say. So yeah, somewhere around 23, 24 kilometers if we translate it. So it's extremely hard to see, but we're also using it, like I said in the presentation, in some hydrofoiling applications. And of course, in hydrofoiling applications, the sort of total energy use significantly drops. It's just during the acceleration phase that you use a lot of power. So of course that expands the range, and also of course the speed matters a lot. If you half the speed, you kind of get a factor 4 range, and so it depends a lot. Going to your second question around defense, I think there is a couple of things into that. Number one, I think, is really the sort of exceptional form factor and how compact our solution is when it comes to weight, but also modularity, how you can integrate it in a lot of different designs. But of course, when you have something which is extremely lightweight, extremely modular, that gives you many degrees of freedom for how you design the rest of the vessel, but also gives you more capacity to either optimize on range or optimize on payload. I think that's one part of it. The second part of it is obviously that we, like I mentioned in the presentation, we have designed everything bottom up ourselves. We don't have any single source dependencies, and that's of course an extremely important factor when it comes to defense. That we can shift around production, we can shift out components, etc. We're not depending on any sort of, any specific components in our solution in that sense. So we have a degree of flexibility, which means we can adapt to a changing reality. Was that the answer to your question, Peter?
Yes, thank you.
Great, thanks.
Great. Do we have any more questions from someone? I don't see any here. Well, from my horizon, I mean, those 4 companies are darlings of mine, so to speak. I've been working with all of those, and actually a couple of more. So this whole area of kind of non-mainstream EVs, I find very interesting, and and it's a little bit hard to because the use cases and the markets are so different between construction equipment and what have you. So it's really hard to see how to kind of accelerate that or leverage each other or so forth. But I'm sure there are, in many levels, ways to actually collaborate and partner between yourselves as well. I hope so, at least.